Hey.
All right. Hey, everyone. How you doing? Hi, I'm Alex Williams, the new stack, and let's just do a quick introduction. We have Benoit Dageville of Snowflake, Ali Godse of Databricks, and we have Murli Turmuli of Portworx. How are you all doing?
Super.
Well, awesome.
Murli, let's start with you. I mean, one of the things I really want to help do here is help people understand what are the differences when we think about data management. And this whole concept of data glut, what does that mean to you? And I'm curious because, one of the things that you really deal with a lot, Murli, is the people who are in the DevOps space and how technologies are really adapting to new application architectures using containers, for example. And so you're really working, with these enterprise companies out there and trying to help them transform to some degree. And I think then there's a different perspective that the two of you bring. So perhaps, Murli, why don't we start with you and just talk a little bit about what it is actually Portworx does?
Sure. So Portworx is a container kind of data platform. So what we're really doing is extending Kubernetes so that we can do storage and data management for Kubernetes, right? So essentially, if you think about sort of a layer cake of what customers are trying to do, let's take a customer, for example, like T-Mobile, one of our best customers. They're taking a lot of the iPhone kind of and iWatch new information and onboarding customers onto a platform that's built on containers. So they're taking their onboarding software, and that's running in containers. It's being orchestrated with Kubernetes, so the containers themselves are being orchestrated by Kubernetes. Now all of that data needs to be managed and orchestrated, and that's the role that Portworx has. So we kind of sit as an overlay on top of existing storage, but what we're doing is ensuring that all of the data SLAs for performance, for high availability, for backup, to ensure disaster recovery is all being managed so that those applications can always be running and ensure that data is always available.
Murli, I want to transition now to Ali, and what Murli was really talking about is how you have to think about data in a wholly different way. It's like this new kind of thinking about data. It's always there. And Ali, I know at Databricks, you guys talk a lot about the way data is used to transform. How do you think about transformation of data, and what are the requirements for it now? Is it batch, which is kind of like just taking data in increments and then being able to transform it into something that you need? And then there's streaming, right, where you can just kind of stream the data all the way through. What is your all's take on it?
Yeah, that's a great question. It depends on the use case. So what we do at Databricks is we basically enable companies that have massive, massive amounts of data, way more than can fit on like a machine or 10 machines or 100 machines, and we enable them to do AI and machine learning on it. So it depends on the use case. So for instance, Regeneron is a big customer of ours. And what they've done is they can actually build a big database of the genomes of all their patients. And they also have a big database of all the diseases that the patients have. And then use machine learning and AI to find out what are the gene sequences that are responsible for those diseases. And they can actually develop drugs then to attack those. This particular use case, it's much more batch-oriented, right? It's like massive amounts of data, and they really want to find that genome that's responsible for that use case. We have another customer, which has actually a chat application that they've built, and they want to, in real time, using AI, be able to detect if, for instance, if there are pedophiles on the network that are pretending that they're 14-year-old, but they're not, and that they want to do in real time. It's really important that they can capture those people. So that's a different use case. We support both. So it kind of depends on the use case. But more and more, we're seeing real-time appear in our customer base.
And Benoit, Snowflake, it's a lot about the data in the cloud, isn't it? I mean, what we're seeing just is this tremendous generation of data, correct? I mean, we have machine data, for example, that's just being, coming out of, for instance, application developers who are using monitoring technologies.
Or, applications are generating a lot of data themselves, weblogs, IoTs, sensor data. So, and this data is really has two base challenges. One is the volume. It's a humongous amount of data, petabytes, many petabytes of data. That's one, challenge. The other challenge is the structure of the data. It's not simple table and columns. So this is called big data. So the challenge of big data is very real. And if you want a company to be really data-driven, you need to analyze also that data with business data. So you need a system, one system, and that's what Snowflake, did is to reinvent data warehousing for both business data and large volume of big data in the cloud, so as a service. And the scale here is super important, right? Because of the volume, you need to scale, not only because of the data, but also because of the users. Every enterprise, and this is what we see from our customers, every companies, today wants to be data-driven. Like everyone wants to, act like Google. Look at data, make decisions based on this data. That means every, employees potentially of a company, will access the data system to make decisions. And the growth of data, the growth of users makes this system very challenging. So being in the cloud where you have unlimited resources is a big plus. That's why we build Snowflake that way.
So okay, Ali, yeah?
Yeah, I just want to actually just agree with Benoit here, especially for machine learning and AI, which is our use cases. People have been doing machine learning for 60 years. It wasn't working for the first 50. What changed? The thing that has changed is what Benoit is saying. Massive amount of data. When you throw that with modern hardware, you actually start getting superhuman results. So the data is really, really important. If you have those massive data sets, you have an advantage. It's the new oil. If you don't have those data sets, you're at a disadvantage.
So Murli, for you, what's the data glut? What is that data glut out there? You guys are dealing with, people who are system administrators and IT operations teams. What's that data glut that they face?
See, the part of the industry that we're facilitating is really around agility, right? Today, not only is there a lot of data, but now that data is coming at them in real time. We talked about real time. There's massive amounts of it. And really, the role of the CIO has changed. About like 10, 12 years ago, the CIO was very focused on the infrastructure in the data center. That was their baby. The care and feeding of that infrastructure, using virtualization, maybe even using infrastructure, renting it instead of owning it. So the focus from infrastructure has now changed dramatically to focusing on apps and data. Apps and data are how the new CIO is going to win and help their enterprise win. So there's different aspects of that apps and data, right? Some of the stuff that we've been hearing from Ali and from Benoit, but there's another aspect of it, which is the applications themselves are changing dramatically. Let's give you an example, right? We've got DreamWorks as a customer. So DreamWorks has people who are creating these new kind of content and new ways to process that data. They have lots of different applications, Maya and other things that do rendering. So they have people who contribute from all over the world. So in this case, it's a proliferation of data coming from different content creators all around the world. How do they ensure that all of this can come to a central place and actually that it will work? And from people who are not experts in infrastructure. Well, the way they do that is to containerize those models, just like genomics. That's another application for us. TGen is a customer which does that. And so containers allow people to rapidly make changes in their applications and deploy them instantly anywhere with a guarantee that it's going to work.
And for those who aren't familiar with container technologies nor Kubernetes, the container is essentially just a process that lives on top of the operating system, and then the orchestrator is Kubernetes that orchestrates all those containers so you can move code around very quickly and then call on the data.
Exactly, Alex. So in a way, you are containerizing your application and making that very mobile and portable, right? Then comes Kubernetes, which takes multiple of these containers, which are, an application can have 4 to 5, 6, 7 containers and hundreds of users. So you have thousands of containers. And what Kubernetes does is orchestrate where those containers land. What we do at Portworx is ensure that wherever the containers land, the data is available. So we provide data persistence. Second thing is, if there's any failure in any part of the network, the container could fail, the node could fail, we ensure that the data is available and when the new container gets spawned. So it's data availability. Third thing is disaster recovery. If you can have whole racks fail, or sometimes parts of a data center fail, or parts of a cloud fail,
right,
we ensure that that data can be recovered and run instantly, and the application runs instantly.
Excellent.
So for us, the idea is that data now is distributed. It's ubiquitous. It's real time, and it's massive amounts of data. Orchestrating all of that at container scale is something that the old storage kind of paradigm just fails to do. Traditional storage is very siloed and very contained, and what we're doing is providing an overlay on top of that that ensures that all of that can still work.
Ali, so when I hear Murali speaking, I'm also thinking about the amount of data that's created from that, right? And just the massive amounts of data that's just scaling up. That creates its own data glut. But in your world, you're transforming data at a rate that makes it manageable. How are you doing that? What is it that makes your technology distinctive in the marketplace? You are a big relier on Spark, which is, maybe you can explain what Spark is to people who may not be familiar with it. And how do you think about that data glut itself, and how do you make it something that's an asset and a value?
Yeah, no, so Databricks actually started out of UC Berkeley research, and we developed 3 popular open source projects that have massive adoption now on the planet. They're not all customers of ours, so those 3 technologies were Apache Spark, Delta Lake, and the project called MLflow. The Spark project enables you to take massive amounts of data and do processing on it. And the way it does it is that it basically turns your data center into a computer. So previously, we used to use a computer to do data processing on, but the computers are not scaling anymore. So what Spark does, it just turns your whole data center into one computer. You can treat it as if it was just one giant virtual computer, and you can now process however much data you want with it. And if you want to go faster, you can just add more machines to it. And we do that in the cloud. So that's one. The Delta technology that we have enables you now to do this really reliably, so that you can actually start bringing in operational requirements into it. You can do it really fast, and now you can actually connect other tools to it so that you can leverage this data that you have for applications like BI. And then the MLflow project now enables you to do machine learning with it. So now you can actually start doing AI predictions, build models that can predict the future for you. So those are the 3 sort of technologies that we combine, and we offer it in the cloud. And the cloud is really essential to what we do. So the technology they develop is really important for us, because the containers, we leverage that to actually be able to move between the clouds. And for our technology to work, you need lots of data. And actually, the cloud is really the only place where you can actually go now and buy data sets. So you might have a data set, you're doing AI on it, your results are not going to be that great. But what you can now do in the cloud is you can buy data sets from other data providers, you can now combine these, and then you get really great results. So the cloud transition is really essential to what's happening here. And I think that it's kind of something that binds us all 3 together.
And the cloud is a very critical aspect, and data is moving to the cloud. You would say now most of the data is born in the cloud, not on premise. And therefore, and the cloud has, offers a lot of options or possibilities, like access to unlimited resources. So Ali was saying, now your platform is a full data center, is a full, cloud region. How to use and to leverage these resources is hard. So Snowflake is a service that allows to run, as many workloads as you want. So traditionally, the challenge was if you wanted to put all your data in a centralized place. So before you can do data-driven decision, you have to have access to the data. That's the first challenge. So you were talking about Glut. The challenge is really how to centralize all the data. But when you centralize all the data, you centralize also all the queries, all the questions that you have on that data, and that's compute resources. So compute resources were becoming the bottleneck. So in the cloud, you can have independent, compute, resources, clusters, accessing all the same data at the same time, but you can scale. So you can add workload, more workloads, more use case against the same data. So the scaling of the cloud is what is really transformational. The data sharing, getting all the data is challenging, because sometimes this is not your data. You need data which is not yours. It was not, created by your enterprise. So data sharing is a huge aspect. The cloud is one single platform where you can, share data. So Snowflake allows you to do that, for example. And data sharing, we see our customers you adopting data sharing more and more. They share data between them, different enterprise.
So what has been the adaptation with data among other technologies that correlate to what you provide? So I think of databases, for example. What is the transformation we're seeing in those spaces that relate to this data glut and relate to this kind of transformation of the data itself? What are you seeing across the entire technology stack that represents that?
Well, there's probably many things that different folks could come to mind, but one thing that I think is incredibly critical in today is all of the things that Benoit and Ali have been talking about are impossible to do without automation. The old, you kind of have a three kind of step thing that's transformation going on. One is just this infrastructure being on demand and being flexible and being distributed, available everywhere and in real time. But when people talk a lot about ML and AI, but really to be able to do all of those things in real time, you really need to automate all of the processes that handle that data and the applications themselves. And one of the things that I think, Benoit and I were talking actually on a different day about this, and it's kind of a crawl, walk, run world, right? People sometimes when as founders and particularly somebody who's kind of selling Kool-Aid of each of our flavors, we tend to kind of talk like about a vision as if it's here now. But customers are kind of making their way to that vision, and in today's world, I think a lot of what people are trying to do is just get the people and the crud out of the system, so people can some of this stuff can actually happen in real time, right? And in our part of the world, that's kind of the role that Kubernetes has played, right? One of the reasons why Kubernetes is such an amazing technology is because it automates the handling of applications in a way that was never, ever possible before. You were talking about stuff that wasn't possible before. Now you can automate thousands and thousands of containers. Why? Because Google was doing it on a project called Borg, which was the internal version of Kubernetes before they open sourced it. So same way, what we're finding is that that's true for data too. Data comes in all types of forms. It's spawned everywhere. We're living in a distributed world. We have customers with sensor networks that are distributing with distributed data. And all of that needs to be moved. And providing data agility requires that it be completely automated. So automation is one of the key, I think, technologies that enable that.
So Elise, when you're thinking of like how people access that data and kind of these next generation of databases, for example, that are corollary to your technologies, what do you think of? What is it that transformations you're seeing in the processes that the technical teams are using inside organizations?
Yeah, I mean, our view is big enterprises have already lots of data in different places. We don't think it's feasible to ask them to move it into a different place or change it or depending on it. So our approach has been, we'll hook into whatever data you have, wherever you have it. We're going to federate into it. Our goal is once we hook into it, how can we democratize it so that the whole organization can actually start asking questions from the data now? So they can start asking, predict from this data set. And so we actually don't care. We're kind of agnostic where your data lies. We'll just access it wherever it is. And whichever system it is, we'll let you hook into it. And we also let you mix it. So you can have it in a traditional database. You can have it in a modern database, like a NoSQL database. We don't care. You can scrape it off the web. We let you do all of that. That's what Spark really enables you to do, to combine and mix and match all the data you have. And then we enable the organization to be able to ask questions from it. So we have a lot of dashboards and, reports, things that actually make it really easy for people that are not
visualization of it.
Yeah, people who are not, super technical. They need to be able to get answers out of the data. If it's just super technical stuff for people who can program, then it won't actually change the world.
Benoit?
Yeah. So database, I think, is a very interesting concept, right? It has been there for many, many years. The new, and it has carried, there is a lot of technology that has been built around databases, like all the tools, visualization tool, BI tools. So everyone knows how to access data with database. It has been normalized with, generally SQL. So when we started Snowflake and founded Snowflake, we wanted to be a new type of database, keep the interface, the SQL interface, keeps, transaction. Transaction is very important. How you change this data, the having consistency in the change of data. If you make a mistake, being able to roll back, being able to go back at any point of time. So transactional aspect of changes is very important, and this is, bring by databases technology. But at the same time, traditional database, they don't scale. Like if you look at technology like Oracle, Teradata, this type of technology, they are single clusters. So they are a bottleneck. They don't know how to deal with big data. So having a new modern system was what we wanted to do with Snowflake. Really more data platform that has all the good aspects of a database, transactions, SQL, but at the same time that we scale and take advantage of the cloud. And that's very important. Yes, you don't want to force enterprise to centralize their data. This is true, and this is hard to do. But at the same time, data silos have really hurt companies. We see a lot of our customers that have created zillions of silos, and they have no, consistent views of their customers.
Right.
Their customers' data is a little bit everywhere, fragmented. So they cannot make good decisions with data that lies, everywhere and which are hard to access. So having one single, data source, one single data platform that can scale, of course, is, really important.
We have less than 3 minutes left, and I would like to just quickly have each of you tell me how what you're talking about is a gateway to machine learning and AI. You use machine learning AI, and you use machine learning in your technologies, Ali, but this seems to be we're in this kind of fuzzy stage. Would you cite it as that, or do you have another kind of perspective?
No, I think we're basically 5 years in to a complete new revolution that's happening. 60 years we've been trying to do AI, but we were doing it the wrong way. We were trying to mimic human brains and using logic and reasoning. We're 5 years into actually now using massive data sets and using statistical AI. And we're just scratching the surface. I mentioned the drugs that were developed. This particular drug was for chronic liver disease. They're amazing use cases, and we're just a few years in. So fantastic things are going to happen in the next 5-10 years.
Really?
Absolutely. I think the advent of on-demand infrastructure with automation of apps and data is really the precursor now to being able to apply AI to massive amounts of data in real time, right? We're going to live in a real-time world. Anybody who's not going to be having real-time systems, they're going to lose. The fast are going to eat the slow. So I think and the precursor of all of this is all the precursor to actually having massive amounts of AI being applied in real time.
Yeah, so I agree with that. I think the fact that you have all this data and you can make decision, but the human is very slow. So you need the machine to make sense of this data, and this is the statistical model. Sometimes you don't know what you are looking for, and the AI is about finding correlation between things. Say, when there are these different data sets, it leads to this outcome, and finding that can be done by machine much more efficiently than by human being, right? Looking at data and trying to find this correlation is hard for human brain. So AI is opening that. The automatic analysis of your data and finding interesting things that's where hard to see in that.
Wonderful. And I'd love to just wrap this up really quickly. We talked about the application layer and how application architectures are being transformed by container technologies. Ali, we talked about the transformation of data overall. And Benoit, I really take away from you this idea that we're talking about data in the cloud.
At scale.
I want to thank you all for participating in this interesting discussion. Thank you.
Thank you.
Thank you so much. Thank you.
There you go.